Assalamualaikum warahmatullahi wabarakatuh. My name is Qaisara Batrisyia Binti Mohamad Sazaly with my metric number 2218076. In this video, I will be present my EECE4351 Radio Frequency Design and Microwave Engineering term assignment. This video consists of two parts. The first one, I will perform antenna characterization using Vector Network Analyzer (VNA), and the second one, I will conduct a free space propagation experiment using a signal generator and spectrum analyzer. Part 1, Antenna Characterization using VNA. For this experiment, we are using HG2614P directional flat patch antenna that operates in the frequency range of 700 MHz to 2.7 GHz. First, we set up the experimental equipment by connecting the antenna to the Vector Network Analyzer, and then the VNA is configured to sweep frequency from 700 MHz to 2.7 GHz, which covers the antenna's operating range. So by using the cursor on the VNA display, we mark all the downward points in the S11 graph, which indicate the frequencies where the antenna is operating. So from the VNA display, we can observe that the antenna operates across the range of 700 MHz to 2.7 GHz with a certain return loss. And the return loss values across these frequencies are ranged below minus 10 dB, which means that most of the input power is successfully transmitted by the antenna and only a small amount is reflected back. This indicates a good impedance matching between the antenna and also the transmission line. Then, we compare the effect of distance between two antennas. So the first one, we try to place the antenna close to each other, and then the distance between the antenna is increased by placing them farther apart. So from the result that display on the VNA, we can observe that as the distance between the antenna increase, the return loss also increase. This happens because less power is coupled between the antennas when they are farther apart, that is resulting in the higher signal loss. So this completes the antenna characterization experiment. Part 2, Free Space Propagation Experiment. For this experiment, we set up the measurement equipment to study free space signal propagation. There is two identical antennas are used for transmitting and receiving. Both antenna are HG2614P directional flat patch antennas, which operate from 700 MHz to 2.7 GHz. One antenna is connected to the signal generator and acts as the transmitting antenna, while the other one is connecting to spectrum analyzer and acts as the receiving antenna. At the signal generator, we set up the frequency to be at 2.2 GHz. The output power is set and displayed in dBm, and the RF output is turned on. So this frequency is chosen because it is within the operating range of the antenna. While at the spectrum analyzer, we use the center frequency to set at 2.2 GHz, which is the same as the signal generator, and use a suitable frequency span to clearly observe the signal, and also enable a peak detection and averaging to obtain a stable and accurate readings. For this experiment, we want to observe the distance variation between transmitting and receiving antenna that are placed facing each other and properly aligned. So the distance between the antenna is set to three different values, which is 0.1 meters, 0.5 meters, and 1.0 meters. So at each distance, the received signal power is recorded from the spectrum analyzer display. From the results shown in the table, it can be observed that as the distance between antennas increase, the received power output decrease. This happens because the transmitted signal spread out as it propagates through free space. As the distance increases, the signal energy is distributed over a larger area, causing free space path loss. Therefore, less signal power reaches the receiving antenna at a greater distance. In conclusion, this experiment helped me understand how RF measurement equipment such as VNA, signal generator, and spectrum analyzer work. I also learned how to set up the equipment, take measurement and observe the antenna performance and signal propagation. I also learned that as the distance between the antenna increased, the received signal power decreased due to free space path loss. So overall, this experiment improved my practical skills and helped me better understand the basic antenna and wireless communication concept. So that's all from me. Thank you for watching.